Everybody, this is Mr. Piercy, and what we're going to be looking at today are properties related with circles and what is known as as a central angle of a circle. Now, if I haven't mentioned it, there's going to be a good amount of vocabulary terms used in this particular unit related to circles, and it's also going to be one of the more algebra dense topics that we're going to be talking about. There's going to be quite a bit of algebra used with our circle properties here. So take a moment, make sure that you get the vocabulary down as far as understanding the difference between what a central angle is, what a minor and major arc are, get all the vocabulary here, and the diagrams, I would encourage you to copy them down just so where you have a visual representation of uh, what you what these terms look like. So that way when you see them in a circle or when you see them in a diagram, you know what you're looking for. Now, one of the things that we're going to be looking at here are measurements of an arc. Now, an arc of a circle, which is kind of like what we're looking at here, this red on top of red doesn't really show up too well. Let's pick a darker color. What we're looking at here, we have this arc AB. Well, that arc there's two ways that we measure it. We have an arc measure, which is in degrees, just like an angle is. Then we have arc length, which is, well, physically, how long would it be if we had to walk from point A to point B along the circumference of the circle? And they're different. Arc measure is done in degrees. Arc length would be like in feet or inches or kilometers, something like that. It would be a linear unit of measure. But once you have, if you haven't gotten all the or all of the definitions here, go ahead and hit pause, get what you need. In the meantime, and when you're ready, go ahead and hit play. But for the meantime, we'll go ahead and move on. So one of the key principles about a central angle is that the central angle and the measure of its intercepted arc will be the same. So for instance, we have a central angle in this diagram. Central angle ACB is 50 degrees. Therefore, the measurement of its intercepted arc AB would also be 50 degrees. Now, anytime that we create kind of this pi wedge here, anytime we kind of create a sector like that, it really kind of divides the circle up into two sectors. It divides it up into a big part and a little part. So in addition to having, so we have a minor arc here, but by creating a minor arc, we automatically create a major arc also. And so that's kind of what we're seeing here with the 310 degrees. And the way that we figure what the measure of the major arc is, if I know the minor arc, is to simply subtract one number from 360 to get the other one. So here in example 1, find the measurement of each arc, where it gives you segment DF is a diameter. So DE, how are we going to look at it? Well, let's look at DE here. So we'll do this one in blue. DE is this arc. DE is using central angle DCE, which is 117 degrees. So that means this arc also must be 117 degrees. Now, looking on here, and I don't want to hit my numbers here because I don't remember if I grouped them all together. Here we want DFE. Well, DFE says I start at D and I have to go through point F and then finally stop here at E. That is the way that we name an arc. Usually that middle letter is telling me, well, I have to go through here to get from where I started at to where I finished at. So I'm starting at D, I have to stop at E, and along the way I have to go through point F. So that's how we know that that's going to be a major arc. So if I look at that and I subtract the 117 degrees of arc DE, then that gives me an arc here of 243 degrees. And let's do red. And so the last one, DEF. Well, DEF goes here. It starts at D, goes through E, and has to stop at F. Now in this case, it's not necessarily a major arc. It does use 3 points to classify the arc, but since it told us that segment DF was a diameter, then that means arc DEF must be a semicircle, which is therefore 180 degrees. So let's go ahead and plug in our fill in the blank stuff here and see what we would have done. At the bottom here, if you haven't already done so, I want you to go ahead and answer this question. If you haven't answered it, go ahead and pause the video and answer problem number 1. And when you're done, come back to the video and see how your answers compare against mine. All right, so hopefully we have a good answer here. We want to find the measurement of arc RTS. Well, RTS, helps if I have a pin turned on. RTS says start at R, go through T, and then stop at S. So we're really looking at that major arc there. So the way I'm going to find that is I'm going to subtract the minor arc that was given to me from 360 and get the measurement of the arc to be 315 degrees. Now the arc addition postulate, remember a postulate is just something you can accept to be true. If I have 2 arcs that I combine, I add their values together. If I have 1 arc that I take away from another arc, we subtract them. We accept that as common knowledge. We accept that to be true. If I combine 2 things, they get bigger. If I take part of one from another one, it gets smaller. It's angle addition, segment addition. Also here we're talking about arc addition. So that's what we're going to be looking at in the example that we see below here. Find the measurements of the arcs. Well, they're giving us all of the angle measurements that we need for the central angles or the arcs, however you want to think of them. And we want to find the measurements of these 3 arcs. So let's find arc BD. Well, arc BD is a really good question here. So does BD go this way in red? Let me pick another color here. Or does it go this way in blue? It's a very good question. Because if I go from B to D in either direction, I have to go through an ancillary point, either point C if I take the red route, or point A if I take the blue route. So which one do I take? Well, here in this case, usually when 2 letters, and I won't say this is 100% of the time, generally, if an arc is only using 2 letters to name it, it's usually going to refer to a minor arc. And again, I won't want to say that is 100% of the time because I have occasionally seen, and it's very rare, but I have occasionally seen major arcs that just use 2 points. So in this case, the arc that we're looking at from B to D would be the arc that I have outlined here in blue. So you just add those 2 segments together, or those 2 arcs together, and we get 116 degrees. So the other one is the BCD. That clears up that because BCD is going to be clearly a major arc. It goes from B, has to go through C, and then stop at D. Well, we already know. Now, here we can do this one 2 ways. If you notice the way that they're setting it up here, is they're saying that the measurement of the arc is going to be 360 degrees minus what we found here, which is fine. But I could also say that the measurement of arc BCD is equal to arc BC plus arc CD. We could have just added those 2 things together and gotten 200 that way also. So that is what arc addition is asking us to do. Pretty common sense. Now here's a really good property that I really like. This is something that causes students a little bit of grief if you don't understand it. What we're looking at here is we're being asked to identify the arcs that were given, are they congruent to each other or are they not congruent to each other? And in order for me to be able to say, yes, these arcs are congruent, there's really two properties that I have to be able to identify. In order for me to be able to say arcs are congruent, they have to have the same measurement. If the arc measures are not the same number, well, clearly they can't be the same measure. They can't be congruent to each other. But not only do they have to have the same arc measure, they also have to come in either the same circle or circles that are congruent to each other, because otherwise they're not going to be the same size. So looking here in example A, BC and DE, are those arcs congruent to each other? Well, in this case, when I look at the measurements of the angles that are given, 75 and 75, well, arc BC and arc DE both have a measurement of 75 degrees, so they have the same measure. And because they're inside of the same circle, then they have to be congruent to each other. So it satisfies the two things that we're looking for. They have to have the same measure, obviously, but they either have to be in the same circle or in congruent circles also. Now, if we look at arc AB and arc CD, both of these have the same central angle, which is measured at 80 degrees. So both this arc and this arc are both 80 degrees. But are they congruent to each other? Well, arc AB follows this path here in blue. And let's say arc CD follows this path here in green. While they do have the same arc measure, if I physically had to walk from point A to point B, it's going to be shorter than the distance from point C to point D is. So because the circles are not congruent, the lengths of the arcs are not the same. And because the lengths are not the same, then the arcs cannot be congruent no matter that they have the same arc measure. And finally, FG and HJ, are those congruent to each other? Well, we know that both of them should be 90 degrees because we have a right angle. So they have the same arc measure. Are they in the same circle? Clearly they're not. But are the circles congruent? Well, in this case, I can conclude that the circles are congruent because even though they're not telling me what the length of the radius is, they are telling me that the radius of the circles are congruent to each other. So because the radius of the circles are congruent and they have the same measure, then I can say that these circles are indeed congruent. So on your assignment, on a quiz, on a test, something like that, if you are asked to say, are these congruent to each other, yes or no, you have to be able to say, yes, they're congruent because they have the same measure and because they're either in congruent circles like we see in A, or, I'm sorry, the same circle like we see in A, or the congruent circles like we see in C. Let me turn the page. Okay. So at this point, again, go ahead and pause the video and answer questions 2 and 3. When you're done, hit play and check your answers with mine. Okay. So going back to example 2, find the measurements of these other two arcs, BCA and ABC. And when you find here, angle BCA is the sum of arc AB, CD, and DA, so that should give you 305 degrees. Finding the measurement of arc ABC is going to be arc AB and BC, so that gives me 195 degrees. Here, question 3, is arc PQ congruent to arc SR? Explain why or why not. Well, in this case, I would say yes, they are congruent because they do have the same measure, even though I have no idea what the number is. They do have the same measure, and because they're in the same circle, that would make them the two arcs congruent to each other. So that's it for this lesson about properties of central angles and the measurements of their arcs. What's the difference between a minor arc and a major arc? Got a good amount of vocabulary here. If there's anything that you are not sure about or you want a little bit more clarification on, by all means, go ahead and email me whatever questions that you have. Leave your questions in the comment section. I'll be happy to get back with you. Otherwise, guys, thanks for watching, and until next time, take care.